All right, so let's try some two-dimensional examples just to get a feel for curl. And I'm really looking for the geometric definition here, right? So I want to calculate the curls using the old definition, and then interpret using the kind of geometric idea at 0, 0. So what was two-dimensional curl?
Partial q with respect to x.
Yeah, that's sort of mismatched partials. So I take the partial of q with respect to x and subtract the partial of p with respect to y. Right? This is the inside of the integral in green. Okay, so I got in f, what's the curl of f1 here? X comma y. 0 reads like. Right? Partial of y of q with respect to x is, partial of y with respect to x is 0. And then I need to subtract the partial of x with respect to y, also 0. So I got 0. What does that mean? Yeah, there's no spinning, right? This is really a, categorically, this 0 is a vector, scalar, what's it?
Oh, the speed is 0.
Yeah, so curl in two-dimensional land, right, is a scalar. Yeah, so these are really a bunch of field lines that stick straight out from the origin, right? So if I think about this, how much tendency is there to spin anywhere? There isn't any, right? And where's that pinwheel? So if I thought about the pinwheel in here, I'm not getting a vector here, right? You guys see that? So where the hell is the vector? It should still be there. I should be able to find it. Where's the vector gotta point?
Towards us.
Yeah, it's gotta point out, right? And it's gotta point towards you to get the, I guess it can point in, right? You guys see that? But it's gotta point either in or out. Out would mean that there's a tendency to spin according to the right-hand rule this way. And in would mean there's a tendency to spin the other direction. You guys see that? So here I got 0. That's at all points 0, right? So what does that mean? Yes, there's never any spinning here. There's no eddies anywhere. Right? There's no tendency to spin anywhere. Cool? All right, how about F2? What's the curl of F2? Of y comma minus x. It reads like 1 minus negative 1 is negative 1 minus 1. Yeah.
So that would spin to the right, right? It'd be like, from your perspective, this way.
Yeah, so what am I getting out of this? I'm getting negative 2 total.
And clockwise is positive, right? Or, yeah, counterclockwise.
Okay, so negative 2, right, means that I'm going that way. So I'm spinning this way. So this is counterclockwise rotation. You guys see that? And the speed is 2. Cool. Can we draw that vector field? Let's just make sure our interpretation's right.
It's a circle vector field, isn't it?
Yeah, let's see. So if I go this point, right, this is 1, 0. What's your vector field? Yeah. Switch. Make the second coordinate negative. Or it's like this guy. And I know this thing's some kind of circulation, right? I recognize there was one that was almost like this that was spinning the other direction. So I'm looking at this vector field, and I'm asking, okay, is there?
Perfect demonstration.
Yeah, it's swastika.
There we go.
Okay, thank God.
Add a few more to that, so the skinhead's not drawing a swastika on the board. See, this is what happens when you let the book pick your examples. All right, so you guys all see that everywhere, right, there's a tendency to rotate. Yeah, and it's clockwise. Right-hand rule says that's going to be negative. Oh, look, it is. Good. Cool. All right. How about this guy? F3. Calculate the curl of F3. This one's going to be weird, right? So this is the vector field minus y minus 1 comma 0. That's going to give me see, so I need a partial with respect to x of q is 0, and then I need the partial with respect to y of negative y minus 1. So it's plus 1.
Yeah, it's just plus one.
That reads like I got 1. What the heck is this thing doing?
Sticking out of the board, like one rotating counterclockwise.
Yeah, so somehow there's counterclockwise rotation here. If you draw this vector field, it looks kind of like this. You guys see that? Okay, so why is it tending to rotate? Like if I put a pinwheel in here, why would it spin around? I'm saying that it's doing this.
You can get more help from the top.
Okay, you guys see that? Right? If I thought about a little circle here, the water's kind of moving faster along the top and slower along the bottom, so yeah, this is going to tend to spin. Is it going to be as fast as it's moving along the top? No, because it's getting canceled out a little bit by the bottom. You guys see that? That's why this is constant. Cool?